Thank you again. Hello, my name is Katoria from the Free University of Brussels, and I am here on behalf of the UNESCO Chair on Open Water Science and Education to highlight some of the work we have been doing trying to promote the applications of open software and low-cost technologies to address water resource challenges. So I will not focus on the project, but I will mostly focus on how IHP-WINS is helping us to store and manage the data that we collect. Next slide. So one of the ways we are trying to bridge these data challenges is by using low-cost sensors. The rationale is that they provide opportunities for us to increase coverage of data collection to areas which are traditionally not reached by conventional methods. And then because these technologies are quite easy to operate, they can be used by trained citizen scientists to cover areas without data. So one example of the tools we are using is this small soil moisture sensor, which collects soil moisture and temperature near the surface. Next. So the nature of our project is we are mostly focused on areas which are traditionally data scarce. So as you can see here, most of our applications are in African countries. We also have some cases in Central America, where our focus is mainly to try and apply these tools in the context of monitoring droughts, environmental degradation, and water conservation. Next one. So the way we are working with IHP-WINS is once we gather the data from the field and do a thorough verification, we upload it through the UNESCO Chair on Open Water Science and Education. The URL is given there. And we, for this project specifically, we provide the data variables you can see there. So soil moisture, air temperature, and soil temperature. The next one. So this is just a demonstration of how the data looks like. So as you can see, once you go to the link, it takes you to this where it describes the data. We describe how it's utilized, some keywords. We also provide some metadata. There is an option to preview or to download the data. If you click on preview, it takes you to this link where you see all the variables we collect. You also have this map viewer where you can pan and scroll to see the locations where we have the data. You can choose which variable you want to visualize, and then you can click on each point. You can see the time series of available data. You can select how many variables. You can also scroll through time to see the data availability. You can change the variables there. Again, you can visualize the different variables. There is also an option to download the data. So the data is stored in CSV format, so you can download it and see. We provide this data in 6-hour intervals. So as you can see there, it's quite easy to download and visualize. Again, we provide some metadata here about the way we collect it and how it's stored. Next slide. Okay, so in the spirit of open science, the data set, we aim for it to fully comply with the 4 principles of open science. So the data is findable through a URL, and we have assigned it a DOI. It's also fully accessible in the sense that it's fully open source. It's interoperable because we provide it in a format, CSV format, which can be utilized across various platforms, and we have also prepared it in a way that it can be reusable. So we provide all the metadata of how we have collected it, how we have calibrated the sensor, and this then enables it to be reproduced for future use. Next one. So this is just to highlight some of the applications we have so far used the datasets in. So we have already tried to compare the soil moisture data with some remote sensing products. We monitor droughts in Malawi at a farm scale. At the moment, we have transferred to another use case where we are trying to monitor soil water retention benefits from deep bed farming. And in Belgium, we are using these sensors to evaluate the water retention benefits in some restored nature conservation areas. So I think if you have been in the citizen science sessions on Tuesday, we introduced our initiatives in citizen science in monitoring water quality. In these two case studies in Bolivia, we are working with the community to try and help them advocate for their environmental rights in regards to water pollution. And in Kenya, we are also working with high school students to help monitor water degradation in our wetland area, and how the data we get from this project can help the community try and reverse this trend. Next slide. So, as mentioned already, we have initially we developed this citizen science project. I would say they were much paper-based. So most of our data collection was on paper, but we found this quite challenging because it involved a lot of data pre-processing and, in some cases, data loss. So we have been working with UNESCO to kind of develop a standardized toolbox which is customizable for each of these projects. So at the moment, we have digitized the paper surveys into a digital survey. They have also managed to develop an Android-based application called Be Resilient. So this survey is well structured. It has all the predefined formats of the data, so there's the units, the time when the data was collected, and the location where it was the measurement was taken. There is also a methodological guidance on how each variable is collected. And then this upload system is both online and offline, so you can just upload the data onto the app. If you are offline, it will kind of stay floating until a connection is established, and then it can then be transmitted. So the advantage of this approach is that it's kind of standardized, so data can be reproduced. So the toolbox itself is an open access platform under IHP-WINS. It's much similar to what we have just discussed in the Open Hydrology part. It has a centralized storage, so the aim is that the data will continue to be available even beyond the end of the project. And we have also tried and developed a visualization dashboard which includes maps to see where all this data is located. Next slide. So here is the link to the citizen science portal. So this you see the digitized survey. I'm not sure it's very clear, but this is a sample of the digital survey itself. So what you would need when you are taking measurements at a point, you get asked the name of the site, the date when you are collecting the data, the weather, for example, the location, and then you will also be taken through each measurement that you are making and the steps that you need to take. So next. So here is just a video demonstration of how the data is stored under IHP-WINS. So this is just a description of the data. I will not go through it. So this is the dashboard where we have the data stored. So what you will see now is how you would fill the data using the digital survey. So you would enter the name of the site. So this is just a demo, the date when you collect the data. It could be faster, but the weather, the locations. So you also have a nice option where you can click on a map and instead of entering the locations manually. And then what you see there now is the different kind of water quality measurements. As you can see, if you click on each, you have instructions of how you would take the measurements, which is useful because then it means we have standardized ways of taking the measurements. Then you enter the measurements. You also have an option to take a photo and upload it alongside the measurements. And then once you're done, you just submit the results. So that's one way of doing it. I'll now hand over to you again to kind of demonstrate how to do it through the mobile application.
Yes, just to add to that, this was actually a way for Katoria that we set up so he could retrospectively upload the data. So this is not the application. In the project that Katoria worked on, the data was collected on paper because the application was not available, or in case you don't have a telephone available or a mobile phone, and you cannot reach the app, you can also do it on paper. Printing these surveys, you can also print them, take them into the field. You will still have the units there, you will still need to fill in the location, and you will still have the guidance. But in case you do have the application, the upload would look like this. You go into the field and you download one of the surveys that belongs to you. You get access by registering on the platform, and then we can assign a certain survey to you so that not everybody can just start uploading data. So you have to fill in the site, you can fill in the date, which it automatically picks. You select the weather as before. The only thing different now is that you actually also need to select your location. Now, with the cell phone, it is easy. You can also, it just tracks the GPS and it will automatically upload your location in case you don't have access to a laptop to go look on Google Earth. So with a certain accuracy, it allows you to upload the location, and then you go to the survey where you add the observations, and the guidance becomes available. You go through it, and before you fill in the actual values. Currently, we didn't integrate the units behind the variables, but this is work that's in progress, which makes it very valuable to just make sure that data is comparable across projects and across geolocations, because this was actually one of the issues that we had in the case of Katoria. And with that, there is again a video how it's portrayed in the platform. I don't think we've shown this yet. So you can go to the platform online to check what you have uploaded. So you go to the map, you select the project that you run, you select the survey you filled in, and then you can, by applying filters, go into data. This visualization platform is a bit more tailored to citizen science than the geospatial view we had before, because we can also upload photos and images of your measurements, of the context of the location where you're at, which allows you to actually see in what way the citizens have collected the data, which makes it also a way of validating whether they collected it correctly. On the right-hand side, you also see the variables that were collected, and you can also make charts. You can see it in the tables, and there's a lot of possibilities to just visualize it, extract it, and analyze it. So with that, this was a short presentation, and with that, I would like to thank you all for listening again to us. I know it's late, but stay with us. Thank you very much.